Hey, it's the last video here for Unit 7. That means test is coming up soon. So we have our Unit 7 Section 4 Proportionality Theorem notes here today. A couple quick things, shouldn't take too long. So let's get started. We're going to start by looking at what's known as the triangle proportionality theorem. Before I actually get to that though, I want to look at an example problem and where it is asking us to solve for x. And I want to show you how we sort of normally would look at this. Looking at these two triangles, what we learned last section was to show that two triangles are similar. And well, if we look at these two triangles, I sort of have this little one, and then I have the big one. So to show that those two triangles are similar, they are sharing this angle here, and because of these parallel lines, I can say that these are corresponding angles. Therefore, those two triangles are definitely similar from angle-angle similarity. So that means to solve for x, I can set up proportions. So if I wanted to solve for x here, what we normally would do is we would say that x, the small piece, is to the long piece. Well, we don't really know what the long piece is. So the long piece we can say is going to be x plus 3, because we're sort of adding these two sides together. And then we could say that that's equal to 10, the small piece there, and then the long side. So the long side, again, we have to add these two pieces together. 10 plus 4 is 14. Then we would have to cross multiply, and that would give us 10x plus 3 is equal to 14x. We distribute the 10, we get 10x plus 30 is equal to 14x. And now we just solve for x like we normally would. When I divide both sides by 4 here, I get that x is equal to 7.5. So that's one way of doing that problem. There's actually a quicker way to do it, and that's using the triangle proportionality theorem. So the triangle proportionality theorem states that if a line is parallel to one side of a triangle, then it divides the other two sides proportionally. So looking at this little triangle over here, I have my two parallel lines here and here. So what that means as a proportion I can set up, I can say that A is to B as C is to D. It's breaking these sides up proportionally. So going back to this example over here, a different way of solving it without having to do all that adding and then the distributing of the 10, we can simply just say that x is to 3 as 10 is to 4. And when I cross multiply here, what you'll notice is that we basically jump right to this point. When I divide both sides by 4, I still get my answer of x is equal to 7.5. So that's the triangle proportionality theorem. Typically, we usually have converses to a lot of our theorems, so we have a triangle proportionality converse. What that says is if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So in other words, all we really want to check is, are these sides proportional? So looking at the side lengths, I want to set up the proportion 16 is to 10 as 24 is to 15. So there's a couple of different ways to see, well, are these the same? You can simplify the fractions and check, are they the same fraction? Or a method that I kind of like is to do this. If you cross multiply the numbers, if you get the same numbers, then that tells you the lines are parallel. So if I cross multiply here, 10 times 24 is 240, and 16 times 15 is also 240. So because those two numbers are the same, I can say that yes, these lines are indeed parallel. The triangle proportionality theorem cannot be used to solve for parallel segments. You must set up a small to big proportion. So if I asked you to solve for, x, and I told you that this was 8, you can't use the triangle proportionality theorem. You have to go back to doing the big and the small parts. So in other words, you would have to add these sides together. So just keep that in mind. Another sort of theorem we have here is stating that if three parallel lines intersect two transversals, then they divide the transversals proportionally. So remember, transversal is just a line that cuts through parallel lines. So let's say that L, M, and N are parallel. What I'm allowed to say then, if these are my transversal lines here and here, I can say again that A is to B as C is to D. Just sort of setting up those proportions there. We have the triangle angle bisector theorem, which states that if a ray bisects an angle of a triangle, then the ray divides the opposite sides into two segments that are proportional. The other two sides of the triangle are going to be in that same order. So again, what that looks like is if I have an angle bisector, and I know it's an angle bisector because I'm showing that those two angles are congruent, what I'm allowed to say is that this piece down here, B is to D, as A is to C. Again, keeping in mind that you're sort of keeping the parts in the same triangles. So B and A are on this triangle, and C and D are on that triangle. So let's take a look at an example of what this sort of looks like. So in this example, we have angle 1 is congruent to angle 2. So by just me telling you that those two angles are congruent, I know I can use the triangle angle bisector theorem. So now we want to solve for x and y here. So notice that x is a small piece and y is a small piece. So we can't actually do this proportion, and I want to show you why. Relating it back to what we talked about up here, it would look like x is to y as 13 is to 7. And well, when I cross multiply there, I get 13y equals 7x. And I can't really do anything with that, so I need to sort of have another approach here. So there's a couple of different ways you can go about doing this, but one way that we're going to look at here is notice that this whole side length is 15. So what I'm going to do is rewrite y in terms of x. So instead of calling y y, I'm going to call y 15 minus x. Because basically if I have this whole piece that's 15 and I break off this piece and take it away, that's going to give me what's left over. So 15 minus x would give me what y is. So now I'm going to switch out my proportion here and instead call this 15 minus x. Now when I cross multiply, that's going to give me 13 times 15 minus x is equal to 7x. And then I distribute like I always do. 13 times 15 gives me 195. 13 times negative x, make sure you watch out for that, gives me negative or minus 13x, 7x. And as always, now we just solve for x. So now this gives me 20x is equal to 195. When I divide both sides by 20, I get that x is equal to 9.75. So now the problem's asking us to solve for x and y. So I solved for x, and now I need to solve for y. So for this, I'm just going to substitute 9.75 in right here. So that basically tells me y is equal to 15 minus 9.75. So y is equal to 5.25. Alright, that is it for the lesson. The next set of problems here are your try-its, so you can go ahead and work on those. Thank you for watching.